Hey there, today we're going to be reviewing skill number 3, which is simplifying expressions in our pre-skills bootcamp. So we're going to dive in on this first video by just reviewing some key vocabulary that we need to better understand expressions in general, so that when we're talking about simplifying, we can use that vocabulary to make sure that we're on the same page. So two very important things we're going to look at today. The first one is going to be this idea of like terms. So like terms are terms that have the same variable raised to the same exponent. So your variable being your x, y, z, d, t, really any letter that represents a number. And an exponent is sometimes what you might say is the small value just on top of a variable. So we'll see what that looks like here in example 2 when we have this square. But for now, let's make sure we understand what a like term looks like and what it does not look like. So for our like terms, if I have the term 5x, a like term might look something like 6x. It has the same variable and it has the same exponent. In this case, we don't see an exponent on this x. We could put an exponent there. That would be the same as having an exponent of 1, but we don't always write the 1. So we don't need to write it here. We just need to understand that if we don't see an exponent, there is in fact an exponent of 1. All right, so a like term could be 6x, it could be 2x, it could be negative 1/3 x. Okay, it could be a fraction as a coefficient, it could be a negative coefficient, as long as it has that variable x with just an exponent of 1, then it's going to be a like term. So to make this even more clear, let's look at what like terms would not be, even though they might look similar. So a like term would not be 5, right? It has the same coefficient, but it doesn't have the same variable. A like term would not be 5y, because in this case, our variable would be y and not x. And a like term would not be maybe this guy, this 5x squared, because I have the x, but my exponent is a 2 instead of a 1. So those would all be considered not like terms with 5x. Okay, and where that comes in is we can only combine like terms when we're simplifying expressions, which we'll talk about more in just a moment. But we just got to make sure we understand what is a like term and what is not. So then let's look at this next example. So negative 8y squared. Some like terms might look like 2y squared. Or it might look like 1/3 or 1/4, let's do a different fraction, y squared. It might even look like a positive just y squared by itself. Okay, so anything that's going to have that variable y with an exponent of 2, that is going to be a like term. Okay, so what is not a like term? A like term might not be negative 8y. Y is there, but it doesn't have that exponent of 2. And then maybe if you had something like 2y to the third, that is not a like term because it has an exponent of 3 instead of 2. So just some examples to help us really wrap our mind around what is a like term and what is not. The second big idea when we get into simplifying expressions is going to be the distributive property. So I know we've seen this before. We're just going to go over a few examples so that we make sure we know how to use it correctly. So the distributive property means we're going to multiply each term inside the parentheses. So we've got a term here of x and a term here of 10. So two terms in the parentheses are going to get multiplied by the number outside of the parentheses. So in this case, I'm going to multiply x and 10 by this value of 5. So let's take a look at what that looks like. So we'll often show distribution by drawing these arrows that shows that I am taking the 5 and giving it to both terms. So if I write this out, this looks like 5 times x plus 5 times 10. And then we can go ahead and simplify. Well, 5 times x is just 5x because we don't know what x is yet. And 5 times 10 is 50. Now, because 5x and 50 are not like terms, that is as simple as this expression can get. Let's look at our next one. This time, I'm taking this -3 that we have out front, and I'm going to distribute it to two terms inside the parentheses, a +2 and a 4y. So let's go ahead and do that. -3 to both terms looks like -3 times 2 minus, so the minus I'm writing down, this is where it can sometimes get confusing. The minus I'm writing down is coming from right here, minus, and then I have this -3 I'm distributing, so I'm going to put in parentheses a -3, and then this is a +4y. And then we simplify. So -3 times 2 is -6. And then I have this minus sign from right here. I'm bringing it down. And a -3 times a +4 is a -12y. And the reason I put it in parentheses is because I have a negative here. And we need to fix that. So when I am subtracting a negative, we're going to notice that that turns into an addition. And that goes back to our integer operation rules. So anytime we're subtracting integers, we can change that into adding the opposite. We reviewed that in our integer operations. So this looks like -6 plus 12y. And again, these are not like terms because the -6 does not have a y and the 12 does. So that is as simplified as it gets. Okay, so we're going to be using both this idea of like terms and the distributive property to simplify more complicated expressions in our next video. But for right now, let's go ahead and move on to our vocabulary check. So the first one says, are they like terms? Then the directions say, examine terms A and B and determine if they are like terms. If the answer is yes, move on to the next problem. If the answer is no, create term C so that it is a like term with term A. So let's go ahead and look at this first one together. Term A is 3x and term B is 3y. Based on our definition where we must have the same variable, I can tell that these are not like terms. So I'm going to go ahead and circle no. And then if I'm trying to make term C so that it is a like term with term A, I need to make sure that the variable that I have is x. So I can pick any number I want, any coefficient. So I'm going to pick -5. And then I'm just going to make sure it has an x attached. Now term A and term C are like terms. So go ahead and finish that to test your knowledge of like terms. And then down below, you'll look at the distributive properties. So I'm going to go ahead and skip down here to the section that says, is it correct? A student used the distributive property to simplify the expressions below. Determine if the student used the distributive property correctly, then explain your reasoning. So if I look at the first one, my original expression was 3 times 2x plus 8, and the student got 6x plus 8. So anytime I'm really looking for an error, I like to just work the problem out myself and then compare. So in this case, I would multiply the 3 times the 2x and the 3 times the 8. 3 times 2 would get me 6x, and 3 times 8 would get me 24. And if I compare that, I can see that they're not the same. So I'm going to say this student is not correct. And the reason is that I noticed that this student only distributed to the 2x. They did not distribute to the 8, and they left that the same. So I'm going to write here, the student only distributed to the first term in the parentheses. So go ahead and go back, review the notes up above if you're getting confused or not sure about what a like term is or how the distributive property works. And as always, ask questions if you're not understanding. Good luck.